Okay, Assalamu alaikum everyone. So in the last class we have done till here. This is the reaction, the substitution reaction of the alkenes. This occurs in the presence of UV rays or sunlight, which provides the activation energy for the reaction to start. And as a result, the hydrogen of the alkane substituted with the halogen. Over here we have used chlorine. So the mechanism of this reaction is called free radical substitution reaction, which we are going to discuss, the free radical substitution mechanism. And we call it free radical substitution mechanism because when this reaction proceeds and the reactants are turning into the products, the radicals are formed. So the first stage of this mechanism is initiation. So let's see what happens in initiation. Yep, very good. So in initiation, the chlorine molecule, the bond between the chlorine atoms is the weakest. So that bond is going to be broken down due to UV rays or sunlight. And what happens? This bond breaking takes place as homolytic breaking or homolytic fission. That's what we have discussed. So what happens? Here we got the pair of electron between the two chlorine atoms. So from this pair of electron, one electron shifts towards the one chlorine. That's why we are using the half head. And the other electron from this shared pair moves or shifts towards the second chlorine. So that's why we are using the half head, because one, not the whole pair, but one electron is shifting. So what happens? As a result, we will get two chlorine radicals. And that's why we use a dot as a power, which shows that they have an unpaired electron, which means they are radical. Yeah, instead of that, you can write 2Cl radical. That is also fine. Okay, so this stage is called initiation. Okay, now after initiation, the second stage of this mechanism is called propagation. So what happens in propagation? What does propagate means? Yes. What does propagate means? To spread something or to transfer something. So that's what happened. In the first stage, we're calling it initiation. And what is actually initiated? The radicals are actually initiated. So in the propagation step, these radicals reacts with the molecules to form more radicals. So as you look at the equation, we have one reactant that is a halogen and the other reactant is a high organic compound, which is right now methane. So these chlorine radicals interacts with methane, and as a result, they turn methane into a radical. So there are two stages of propagation. In first stage, let's see what happens in the first stage. The chlorine radical interacts with methane radical. And in the initiation, what happens? The bond of the chlorine is broken down. Over here, in this propagation step, what happens? The bond of carbon-hydrogen broken down homolytically again. So from this pair of electron, one electron moves towards the hydrogen and one electron moves towards the carbon. So as a result, hydrogen radical and the methyl CH3 radical are formed. So the hydrogen radical, which is formed over here, bonds with the chlorine, forming HCl molecule. And we are left with this CH3, where carbon had one unpaired electron. So see, chlorine radical is turning a organic compound into a radical. So that is the first step or first stage of propagation. Is this clear? Any confusion so far? Okay. Now, in the second stage of propagation, what happens? That this radical reacts with a chlorine molecule. And now chlorine molecule do the same thing. It breaks its bond homolytically, means from the bonding pair, each chlorine get one electron. Actually, the thing is that these all reactions are taking place randomly. It doesn't mean that after this is going to happen. There might be a possibility that one methyl molecule and one chlorine molecule, one methane molecule and chlorine molecule both break their bonds. Okay, so as soon as this chlorine forms and from here the hydrogen form, they both join. So there is no proper order of these reactions. We are just showing what are the possible reactions which are taking place. But there is no, no order or no sequence. Beside this one, we can say that is an initiation that takes place at first because this bond is weaker as compared to the rest of the bonds. But beside this, these reactions occurs randomly. There is no sequence. Yeah. Okay. So these propagation reactions occur randomly. So it means that, for example, let's have a look. Initiation occur and we got two chlorine radicals. Okay. Now, the first chlorine radical interacted with the organic compound and turning into a radical and forming HCl. Now, there might be a possibility after this, another chlorine molecule which is undergoing the initiation, its initiation, during that, this methyl molecule started interacted with this one. So these occurs without any sequence, except the first stage, the very first molecule broke their bonds and turned into chlorine radical. After that, all of the reactions occurs in the random sequence. Assalamu alaikum, Farhan, how are you? Okay, so what happens over here? That one chlorine, as they both chlorine, the chlorine molecule breaks its bond homolytically. So we got one chlorine radical, but the second chlorine radical over here joins with this, forming our product. See, because when this chlorine joins with this, what we will get? We will get CH3Cl, which is our product. So it means beside our product is formed and HCl is formed. These were we have mentioned in the equation. So over here, I'm going to show this one with one chlorine. Is this clear? Okay. But why I'm calling these two stages a propagation? Because at the end, we are getting a radical. So that's why it is propagation. Start of the equation, we have one other radical. At when the reaction when this stage is done, we got another radical. Similarly, over here we have a methyl radical, but when this methyl radical is reacted, we will getting one more radical, another radical, which is chlorine. So after propagation, the third step, that's what we called termination. So termination, what does termination means? To terminate something, to end something. So over here, the radicals are being terminated. So how many different types of radicals are formed? No. How many different types of radicals are formed? Two. One is a chlorine radical and one is a organic compound radical, that is a methyl radical. So in termination, what you will do, okay, another important thing, in termination, you are not going to mention the condition because sunlight or UV rays are needed to break the bond. And over here, I have mentioned this condition because in each case you are observing there is a bond breaking. But in termination, what is going to happen? The radicals are going to be terminated. The two radicals are going to be formed their bonds and turning into a molecule. So when the bonds are formed, there is no energy is needed, right? So how many kinds of molecule radicals are 2. So we are going to make the possibilities of their all combinations. So for example, one possible combination would be that both the two chlorine molecules join with each other, forming a chlorine molecule again. The second possibility would be two methyl radicals join with each other, because these all are radical, right? So they are going to share their bonds with each other. And the third possibility would be that a methyl and a chlorine radical joins with each other, forming C. Yeah, you can write in the formula form. I have just shown how they are being bonded. Okay. And over here, you can also put a half arrow from these unpaired electrons, which shows that they both are sharing their electrons. They both are sharing their unpaired electron with each other to form a bond. Is this clear? So see, in the first step, that is always initiation. The second step is propagation, and propagation has two reactions taking place. In first reaction, the organic molecule interacted with the halogen radical, forming the organic radical and a HCl. Then the organic radical formed in the first stage of propagation reacts with a new chlorine molecule, turning into your product and chlorine radical. Then we will show the termination step, and termination step will show all the possible combinations of both the radicals. So see, we are getting this as twice. So that's why we have mentioning over here along with HCl. And it means this is also formed, but it formed in a very less quantity. That's why we don't show it in the actual equation. But when we study the mechanism, we will find that there are more products which are being formed along with the products that have mentioned in the reaction, in the chemical equation. Is this clear? Yes, Farhan, did you understand? Okay. Now, if I ask you and give you the equation 2, and I ask you to draw the mechanism for equation 2. So now we are going to draw its mechanism. So it means that again, the initiation state would be same, right? Because there is a chlorine molecule. And if there is a bromine, so I'm going to show the initiation stage with the bromine molecule. Okay, yeah, he again left. Okay, so after initiation, the next stage is propagation. So who will tell me what will be the propagation, the equation of the first equation of the propagation step? Okay. Because we have this molecule right now, CH3Cl. So we are going to, okay. So let me take this one and make changes to this one. So now, as you can see, our reactant is CH3Cl. So what I'm going to do, I'm going to just remove one hydrogen and show a chlorine over there. Same thing. So our radical formed would have a now chlorine already, because that one chlorine is already substituted. And then now we will get a CH3Cl2. So see, now this is our reactant. So I've used over here the carbon with one chlorine and three hydrogens. One hydrogen gets removed, so we will get a CH2Cl radical, and that CH2Cl radical reacts with another chlorine molecule forming CH2Cl2. That is your product, and a chlorine radical. Sorry.
Initially, it's CH3.
Yep.
Second one is CH2C. Second one can't happen.
Yeah, this bond should be broken.
This one has to be.
Yeah, this bond should be broken, but there are two possibilities. For example, when this bond should be broken and this is formed. So after formation of this can either go for a propagation, or this could either go for a termination as well. Yeah, that's what I have told you initially, that this bond should be broken very first, and after that this bond is broken. So the bond breaking, then when the bonds are going to be formed, they are obviously going to be randomly. But as we can see that initiation should occur at first. So similarly, it's obvious this bond should be broken at first. But after breaking of this bond, as we are getting HCl over here, but there might be a chance that this H would join with, as it is forming a radical, it might join with some other radical as well. But the chances of that formation of that compound would be very low, that we were not showing that one in this mechanism. So yeah, this bond should be broken first. This bond should be broken first. After the breaking of a bond, then obviously the new bonds would be formed. But yeah, there is a possibility, but obviously after formation of a bond, because it already become unstable, its octet is not completed, right? So it will not go for breaking another bond until it will complete its octet again. Okay. Now the next step is termination. So again, we are going to see the three possibilities of termination. And what would be the difference over here? Only the difference is in the organic molecule or the organic radical. Instead of CH3, okay. So we have a chlorine over here, right? So over here we will get this product. And as we have a chlorine over here, so we will get this product. Is this clear? Any confusion so far? Okay. So for equation 3 and 4, draw mechanism, and that's what I will check in the next class. That is your homework. These two, equation 3 and 4. Okay. Done? Okay. Now, right now, I want you guys to draw one mechanism. This one. Mariam, do it quickly. Okay. So initiation is always same. And put the arrows to show the bond breaking. And remember, half arrows always show that one electron is moving towards that atom. No, I just want you to do it. Yeah. So it will be more understandable because you need to decide which hydrogen is going to be removed. That is really important. Yes. So it is going to be removed from the carbon on the right or carbon on the left? The carbon on the right, because if you compare the reactants and the products, you will find that the reactant side, the carbon on the left already had two hydrogens, and in the product, it also has two hydrogens. But the carbon on the right has two chlorine atoms and one hydrogen, but in the product, the carbon on the right got all three chlorines. That is hydrogen. Now first put the arrow to show which hydrogen is going to be broken down. Yeah, so the vertical bond of a carbon and hydrogen. Yep. One half head towards the carbon and one half head towards the hydrogen. Yep. And one from the bond to the carbon. Yep. Yes, so it shows that from this pair of electron, one electron is shifting towards the carbon and one electron is propagation. In propagation, we always get a one molecule and one radical. So you don't put the chlorine over there. From where the hydrogen is removed, just keep it removed and put the radical, that carbon, make that carbon radical. See this, like this. Because we have only one chlorine, right, in propagation step, and that goes with the hydrogen. Now in second step, this carbon, which is a radical, takes the chlorine from a chlorine molecule. Bond, chlorine. And now show the bond breaking of a chlorine. First show the bond. Yep. Good. And all of these stages need the sunlight and UV rays because in these bonds are being broken down. Then we have a termination. In termination, that both the radicals join with each other. So one way is that both chlorine radicals join with each other, forming chlorine molecule back. Just move it a little down. There is no space between the two equations. Yep. Yes, now you are going to join both these radicals from the carbon which has unpaired electron. Yeah. It's better to put that chlorine which you put on the right side, put above. Yeah, put that chlorine above and yeah, the carbon with both the carbons which are being bonded, they both have two chlorines. Yeah, one organic radical and one Cl radical. Both the organic radical and the chlorine radical, we will show all the possible combinations of both of them. One chlorine radical, one reaction where two organic radicals joining with each other, and then one reaction where one chlorine and one organic reaction joining with each other. Thank you, Maria. CH2, CH3, Cl3 right now. Otherwise, the starting material reactant would be ethane, C2H6. No, that is not propagation. That's what I'm going to discuss right now after this. That was the question like this. For example, if you have a ethane and when you react with the excess of chlorine, so it means all of the hydrogens are going to be substituted. So how many possible organic products are formed? Yeah, and you will count how many products you will get. Yes, is this clear? Any confusion? Ahmed, okay. So sometimes in MCQs, the examiner asks the question. For example, the question is like this. With excess of chlorine, how many possible? So this is the organic compound which is reacted with excess of chlorine. How many possible organic products will form? Yes. Yes. How many possible organic products will form? 8. I'm talking about organic products. 7. Yes, Ahmed. Organic products. It means HCl is not included. HCl is not organic. 7. Yes, Mariam. 7. Okay. So can you explain why do you think that 7 products are formed? So these are the intermediates. These are not the products. Okay. So products means, for example, this is C2H6. When it reacts with first reaction, it will turn into C2H5Cl. then it would turn into C2H4Cl2. So similarly, all the hydrogens get displaced. So how many organic products would form? 6. Okay. So that is the most expected answer, and that is the wrong one. Actually, yeah. We will get 9 organic products. Yes. So have a look how. No. See, when I'm going to remove the first chlorine, when the first chlorine is going to be substituted, it doesn't matter whether this chlorine goes over here. All of these 6 positions are equal. Wherever the chlorine get, that chlorine become the molecule would become 1 chloroethane, right? Now, when this one would react with the another chlorine, now we got 2 different possibilities. If chlorine got over here, then what organic product we will get? 1,1-dichloroethane. Or if instead of this, if a chlorine got over here, 1,2-dichloropropane. So instead of 1, actually we are getting 2 ethane, sorry, 2 different possibilities, 2 different structures. Is this clear? So see, the second product and the third product. Now, if you look at the third product again becomes symmetrical, right? So now all these 4 positions becomes equivalent. So it doesn't matter where the chlorine gets substituted, you will always get this one, right? But when this chlorine would react, again, we have our 2 possibilities, whether the chlorine goes to this place or whether the chlorine goes to this place. So it will form the same thing which is formed by this, and it will form another possible product, this one or this. So it is going to form these 2, right? If you look again, see, okay, let's have a look from start. Over here, it doesn't matter where the chlorine goes, it is always 1 chloroethane. But when 1 chloroethane reacts, there are 2 possibilities. Either it will form 1,1-dichloroethane, or it will form, so actually it will form these 2, because you cannot control that on which carbon the chlorine is going to be bond, or on which carbon the chlorine displaces the hydrogen. So after 1 chloropropane, you are actually getting 2 products, not 1. Is this clear? Yeah. So total we got 3. Now, if you look at the second product, which I have marked second, when it reacts, it again going to form 2 more products, isn't it? The product number 4 and the product number 5. And the product number 3, which were formed from the 1, is actually going to make only 4th one, because it is again symmetrical molecule. So see, in total, how many products we will got? 5. Now, if you look at 5, when 5 reacts, it is actually going to form only 1 product, because all of the 1 carbons chlorine are substituted, and it is going to make another carbons, another hydrogen on another carbon, right? So you will get this one. But when you look at this one, the 4th one, it is also going to form this, but it also forms this one as well, isn't it? So we got 6th and 7th product till here. Now, when 7th has 2 possible, 7, when 7 can go next chlorination, it will form the 8th product. 6 also formed that 8th product, but still 1 hydrogen is left to be substituted. So when we are finally going to get C2Cl6, in total we are getting 9 products. So that's what usually when sometimes examiner asks this MCQ. So the better way of when you have any MCQ where you can see that there is they are asking about the isomers or the products where there are options which have 5 or more than 5 structures. So I always suggest students to leave that question, because you have only 1 minute and 15 seconds for each question. So just leave that and save your other marks, not spend much time on this one question. Because, for example, if you have spent 10 to 15 minutes on this question, so it means you lost next 10 to 12 MCQs. So it's better to save that question for the end when you are done with all the MCQs. If you have a time, then work on it. Otherwise, just if you are losing 1 mark, that is fine. Instead of losing 12 or 13 MCQs. Yeah, that is fine. Yeah, so always go for a greater number. Whether you will get 1 mark or not, that is fine. That is fair enough instead of, risking 12 or 13 MCQs. Okay. Now, so here we are done with the free radical substitution. Now we are going to discuss the nucleophilic substitution. We have discussed in the last class as well. Can anyone recall which homologous series undergo nucleophilic substitution? No. No. Very good. And alkenes undergo free radical substitution. Halogenoalkenes and alcohols undergo nucleophilic substitution. Okay, so we are going to discuss the nucleophilic substitution reactions now. So when we talk about the halogenoalkenes undergo only 3 types of nucleophilic substitution reaction, and you need to remember the reagents, the conditions, and the products. So that is really important. So here we have 3 nucleophilic substitution reactions of halogenoalkenes. So see, it's a halogen. I have mentioned X over here, which can be chlorine, which can be bromine, which can be iodine. Okay. When it reacts with aqueous sodium hydroxide, the halogen is displaced by OH and you will get the alcohol. You need to remember the condition that you are reflexing it. Reflexing is a specific type of a setup in which we heat the substance. We are going to discuss later what actually reflexes. So remember the condition is reflex. The reagent is sodium hydroxide in aqueous state, and as a result, the halogen is displaced by the OH group, and the sodium halide salt is formed, which could be sodium chloride, sodium bromide, or sodium iodide. So we are getting alcohols from the halogenoalkane. Is this reaction is clear? Okay. Now the second reaction, if you see, you have a potassium cyanide or sodium cyanide can be used. Let me zoom in. So you can react the halogenoalkane either with potassium cyanide or sodium cyanide. But over here, see, here what is the solvent? Aqueous, it means water is no. NaOH is the reagent. The solvent is aqueous, it's water. Over here, what is the solvent? Ethanolic. So it means these reagents must be dissolved in ethanol, not in water. So that is the specific condition. And when we use this reaction in the ethanolic conditions, this CN, the cyanide ion, displaces the halogen, forming the organic compound, which we call nitrile. When the CN bonded to a alkyl chain, that becomes nitrile. So as nitrile is formed, the halogen is displaced. That halogen bonds with potassium or sodium, forming potassium salt of halide or sodium salt of halide. Is this clear? Okay. Now next reaction is with ammonia, and again see, ammonia is also dissolved in ethanol. Okay. So see, the conditions for the first 2 reaction, it's reflex. But over here, it is heat under high pressure. So this is the only reaction in the organic chemistry where we need the high pressure. If I'm talking about the AS aspect. So sometimes instead of heat under high pressure, it is written heat under a sealed tube. So if it's a sealed tube and you heat it, it will make the pressure increases. So as a result, what happens that the NH3, from NH3, NH2 displaces the halogen, right? So what is left behind from this NH3? 1 hydrogen. That hydrogen bonds with halogen, forming HX. So HX could be HCl, HBr, HI, which is acidic in nature. And there is also ammonia. So ammonia is a base. And this is acid. So acid-base reaction occur, and as a result, we will get the ammonium salt. For example, if HCl is formed, so it will finally turn into ammonium chloride. If HBr is formed, it will finally turn into ammonium bromide. Is this clear? Now here is my one question. Which kind of reaction is this? nucleophilic substitution. Okay. Only here we are using water, but why we are not using water as a solvent over here? How is there water coming in over here in the product? We are using water over here as a solvent, right? Yeah, but over here also we are not getting water in the product, right? Yes, Mariam. Yes, Ahmed. Why we use ethanol as a solvent instead of water? It's an ionic compound, isn't it? Hmm? That is present in water, yeah. Okay. No, not from these properties. Actually, I gave you the hint. It's a nucleophilic substitution. Now think. In this, what is being halogen is displaced by OH. So it means OH is actually a nucleophile, right? So if it's aqueous sodium hydroxide, Mariam, be focused. So there are sodium ions, hydroxide ions, but as it's a aqueous, so it means there are hydrogen ions and hydroxide ions. So we have only one nucleophile, that is hydroxide ion, which is coming from the sodium hydroxide as well as water. For example, if I made it aqueous, so I have cyanide ion and hydroxide ion both, isn't it? Yeah, sodium is positive, right? So cyanide ion is negative. That's why it is displacing the halogen, because it's a nucleophile. So there is a cyanide ion and hydroxide ion. So if I have used the aqueous sodium cyanide, so I have a two different types of nucleophile. I have a cyanide ions and the hydroxide ion. So I don't just get the nitrile. Besides this, I am getting the mixture of the nitriles and the alcohols, because we have now two different nucleophiles over there. So that's why we are using ethanol, because ethanol itself doesn't dissociate. It will just make this as a nucleophile, and we have only one kind of a nucleophile, which is cyanide ion, and which attacks the which attacks the carbon on which the halogen is bonded. Similarly, if it's ammonia in ethanol, again we are getting ammonia as a nucleophile. But if I use ammonia aqueous, so it will form the hydroxide again. So instead of not just getting amine, we are getting amine and alcohols both. So that's why we are using over here ethanol. That's why we are not using aqueous ammonia and aqueous sodium cyanide and potassium cyanide. Is this clear? Okay. So this is what you need to remember, what conditions are needed. Now yes. I think 4 mechanisms in AS. When we are done with, now we have 3 more. No, yeah, we have 4 more to go. 5 mechanisms are there. Okay. Yes. We will able to do it in mid of April, inshallah. Okay, now have a look. These are the nucleophilic substitution reactions of alcohols, and that's what you need to remember as well. So see, when you read, okay, so in these reactions, then this is the one thing which is good, that will make you guys to remember it easily, that in all of these cases, whenever alcohol undergo nucleophilic substitution, it will always turn into halogenoalkane, nothing else. See, when we are using PCl5 with RTP, at RTP room temperature and conditions, hydroxyl alcohol turns into a chloroalkane. These are the byproducts. SOCl2, again, there is no condition needed RTP. We are getting the chloroalkane. The OH, chlorine is displacing the OH. The byproducts are different. Then if we are using the PCl3, so for PCl3 we need heat. The first two reactions occur at room temperature. So again we are getting the chloroalkane, and H3PO3 is the byproduct. Okay, this equation is not balanced. Over here I have written the balanced equation. Okay, now see, this is the important thing over here that you need to remember. If I'm making from PCl5 I am making chloroalkane, so it doesn't matter. It doesn't mean that with PBr5 I will make bromoalkane. Okay, so see, this is the case. If you need a bromoalkane or iodoalkane, what you need a hydrogen bromide gas or hydrogen iodide gas. When you react either with hydrogen bromide gas or hydrogen iodide gas, you will get the bromine or iodine substituting the OH group, and as a result you will get water as a byproduct. See, one more thing, that actually that bromine and iodine are really large atoms, so they won't even form this compound like this because of their bigger sizes. Chlorine is relatively smaller. And the other thing, like if PCl3 is being used, PBr3 and PI3 are not used because we need to make them in a real time because they are unstable. So see what we do, we use a red hot phosphorus with the bromine, or we use red hot phosphorus with the iodine. So what happens in the reaction vessel, they reacts in the real time forming PBr3 or PI3. And then that will undergo the same reaction. Over here you will use PBr3 or PI3 in this equation. Over here, you used either chlorine or bromine, and H3PO3 is formed. And then see, over here we are using hydrogen bromide gas or hydrogen iodide gas. For HCl gas, you need to react sodium chloride and sulfuric acid in the reaction vessel. That reaction vessel has a specific name which sometimes examiner asks. We call it SIT. So we got the mixture of alcohol, sodium chloride and sulfuric acid in that C2, and on heating, first sodium chloride and sulfuric acid reacts to give to hydrogen chloride, and that hydrogen chloride reacts with the alcohol forming CH chloroalkane and water. So this is what you need to remember, and how you will able to remember. If you just want to read and make sure that you will remember everything, it's not. You always need to do the past papers by keeping this in front of you. So when you do multiple past papers with taking the help from this, then it will brainstorm in your mind and you will be able to do it. But you can start the past papers. Okay, you just right now leave organic, but beside organic you can, but when you start the organic, but you have after this but you can do half of the organic past papers, because when you go over, you will find majority of a reaction of alcohol and majority of a reaction of halogenoalkane. So you just look at the condition, or you will look at the reagent, you will find, yeah, if it's sodium hydroxide, you will make alcohol from halogenoalkane. For example, let me give you a hint. Example, let me open a past paper. So till now, okay, you guys know combustion, right? We are done with the free radical substitution of alkanes. We just go over the nucleophilic substitution reactions of halogenoalkanes and alcohols. So at least you can do the past paper. It doesn't mean that you are not able to do the past paper. Let me open a yearly paper. Files. Okay. Yeah, I know. For example, if you look at this reaction, see this. Okay. For example, if you are doing organic right now, complete the equation, shows reduction of propanoic acid to propanol. So are you guys familiar with the propanoic acid? Are you guys familiar with the propanol? Use del H to represent one atom of hydrogen from Q. So see, it means, see, they have drawn the propanoic acid. They have written this. So what I need to make? Propanol. So CH3, CH2, CH2, OH. Is this clear? Now see, how many hydrogens we have over here? 6. And how many oxygens we have over here? 2. Over here, how many hydrogens? 8. And how many oxygens? 1. So it means one oxygen is removed. So obviously that oxygen makes water. Now in total, there are 8 and 2. How many more hydrogens we got here? How many more hydrogens? 4. Here we have 6. Total, we got 4 more oxygens. So I'm going to put 4 over here. So we'll do the same thing. We will make 2 moles of water and then we count the excess hydrogen. The extra hydrogen, we will put a coefficient over here. If, for example, 2 hydrogens are being lost from here, I will put 2 over here. So then I will count the hydrogens from here. The change in hydrogen, I will put it over here. Is this clear? Okay. Now, if you look at this next question, propanol is converted to compound T in a 3-step. In a step 1, SOCl2 is added to propanol to produce compound E. Yes. That's what we have just seen. At room temperature, SOCl2 reacts and OH displaced by Cl. Nucleophilic substitution. Name the type of reaction that occur in step 1. Nucleophilic substitution. Identify the reaction and conditions in step 2. Okay. In step 2, E reacts with a suitable reagent to produce butane nitrile. This reaction we have already discussed today only. See, for example, yeah, very good, heat under reflex. Propanol, when reacted with SOCl2, it will form into compound E. That compound E must be CH3, CH2, CH2, Cl, right? Because SOCl2 is reacted. That's what we have just seen. Have a look over here. Yep, very good, Mariam. So see, when alcohol is reacting with SOCl2, we will getting OH is displaced by chlorine. Right, Ahmed? Okay. Now we got this. And we have just studied its reaction over here. So if you read the next part, what examiner is saying, that in step 2, E reacts with suitable reagent to form butane nitrile. We know nitrile means C triple bond N. So if this is turning into, it means this is actually turning into CH3, CH2, CH2, and then Cn. This Cl is substituted by Cn. So what was the reagent for this one? Here you can see KCN or NaCN. So that halogen replaced by Cn. Is this clear? No, 1 minute. So in this reaction, identify reagent and condition. So reagent was NaCN in ethanol and heat under reflux. Okay, now over here, that is a nucleophilic substitution. That's what we have discussed. And actually, both of the reactions are nucleophilic substitution. Reaction 1 and reaction 2 both are, right? Okay, construct an equation to describe the reaction of butane nitrile with NaOH. Yeah, that reaction we haven't studied yet. Right? That is the hydrolysis. Name the type of this reaction. So reaction 3 we haven't studied. Basically, it is hydrolysis. We are going to study this one. So see, it doesn't mean till now we have covered enough content that you can do partial organic questions. Okay. Okay, so these are the reactions that what you need to remember, and you can remember them by practicing. Okay. Yep. So the next thing is we have discussed the 3 different types of carbocation, that there are primary. Yes. The primary carbocations are the one where the positively charged carbon is bonded to either all 3 hydrogens or 1 carbon chain and 2 hydrogens. Secondary carbocation is the one where it is bonded to 2 alkyl chains and 1 hydrogen. And tertiary is the one which is bonded to 3 alkyl chains. And tertiary is the most stable. Their stability we have discussed in the last class. Okay. I think we haven't done isomerism, right? I have moved to the reaction. Okay, so we'll do it after the reactions. Need to draw the different structural formulas, the functional group isomer, the site, the chain, and then we have a stereoisomerism as well. Yeah, cis trans and optical. No, when did we study? I don't think so. Yeah, we haven't studied. Okay, so if you identify the type of a carbocation, then you can, easily identify the type of halogenoalkene and the alcohol as well. For example, you can see that these are the primary carbocations. So if I put the OH over here, so it means this alcohol becomes a primary alcohol. If I put a halogenoalkene, similarly, this one is a secondary alcohol. This one is a tertiary alcohol. This one is a secondary chloroalkane. This one is the tertiary chloroalkane. So we can identify the halogenoalkanes and the alcohols on the same basis as we have figured out or as we have categorized the carbocations. Is this clear? So the classification of the carbocations and the classifications of the halogenoalkanes or alcohols are exactly the same. Okay. Now, we are going to discuss the first mechanism of the first nucleophilic substitution mechanism. And that is the nucleophilic mechanism of the halogenoalkanes. See, we have a halogenoalkane that is reacting with sodium hydroxide in aqueous condition, and we know that the halogen is displaced by the OH group, forming an alcohol. Okay, now if you look at this halogenoalkane, the halogen is bonded to a carbon. That carbon has CH2. So it means it is bonded to 2 hydrogens and 1 alkyl chain. So it indicates that it's a primary alkyl halide or primary halogenoalkane. So remember, primary halogenoalkanes always undergo SN2 mechanism, and that's what we are going to study right now. What is SN2 mechanism? Okay. So in these mechanisms, you need to make partial charges, you need to make dipoles, you need to put charges, you need to make lone pairs, and you need to make curly arrows. Okay, so the mechanism is easy. So see, this is a primary halogenoalkane. Why? Because the halogen is bonded to a carbon. That carbon has 2 hydrogens and 1 halogen or 1 alkyl chain. So that is a primary halogenoalkane. It is same as we classify the carbocations. If you recall the carbocations, see, I have made the comparison. These are the primary carbocations we have discussed in the last class. Right? This is the secondary one because it's bonded to 2 carbon chains and 1 hydrogen. And this one is the tertiary. So if I put the halogen to this carbon, as it was a primary carbocation, so this whole molecule become a primary halogenoalkane. And for example, if I put a OH over here, so this whole molecule become a primary alcohol. Is this clear? Yes, Nile. Yes, Ahmed. Okay. So now let's move to the mechanism. For example, this is a primary halogenoalkane. So how this molecule turn into a product? So first, what you are going to do? You are going to, yeah, make the halogenoalkane. That is your first step. Will make the halogenoalkane. That is your first step. The second step, you are going to make the nucleophile. So what is the nucleophile over here? OH, right? OH is the nucleophile which is displacing the halogen. So I'm going to draw the OH over here, and as it's a nucleophile, what was the definition of nucleophile? Yeah, that's what we say. But how can you define a nucleophile? What? Very good, Nile. Has a lone pair. So if you are showing the nucleophile, you must need to show the lone pair on it. Yes. Yes. So now what I'm going to do? Now I'm going to put the charges, put the dipoles. So I'm making it colorful with the numbers. So you know that this color, so you know the order what you need to do. So this carbon is going to be partial positive and this halogen is going to be partial negative. So if it's a dipole, so how this bond breaking would occur? Homolytically or heterolytically? Heterolytically, which means the whole pair is taken away by the bromine. Bromine snatches the electron of carbon as well. So what happens at the fourth stage, that this OH with the lone pair attacks this carbon. So over here, I'm going to use the whole head because the whole pair is moving. And over here, from this bond to this bromine, I am again going to make the whole head because this whole pair is going towards the bromine. Is this clear? Okay. Now, as a result, these two occur simultaneously. Okay. These two, this attack of a lone pair and this snatching of the pair of bond pair attacks simultaneously, occurs at the same time, which results in the formation of a transition stage. So the transition stage would be like this. See the rest of the three things bonded to a carbon. You put these three things below and above the carbon. So there are two hydrogens and one CH3, right? Now, this bromine, its bond is going to be broken down. So I'm going to show it with the dashed line and put the bromine at the end. And the oxygen of the OH is making the bond. So I'm again going to put this with the dotted line, which indicates that this bond is being made. Now, over here, what students do the mistake after this, they write OH like this. So if you do this, it is wrong because see, the oxygen is the one which is sharing the electrons to the carbon, not hydrogen. So when you are going to write it over here, O must be facing the carbon because O is the one, oxygen is the one which is sharing the electron to the carbon. Is this clear? Okay. Now, as a result, this is the transition state. It is highly unstable stage. That's why I put it in the square bracket. And it is negatively charged because there are two negatively charged species are there, the OH and the bromine. And then finally, the bond is completely broken down. The bromine come out by taking the whole pair of electrons. So it's necessary to show the pair of electron, the lone pair with the bromine and the negative sign. And then what we are left with? We are left with carbon, which is bonded to CH3. It has two hydrogens to it. And now it got the OH. So that is the mechanism. That is the SN2 mechanism. That is who always do this. The primary halogenoalkane do this. Is this clear? Okay. So in the middle, you can see the transition stage. In this transition state, the carbon is forming how many bonds? Yeah. How many bonds are there? If you look, there are 5 bonds of the carbon. That makes it highly unstable. Okay. And over here, both bond breaking and making takes place simultaneously. Okay, so we are not doing anything new. Okay, just I want you to draw one mechanism like this only. Then you guys will leave. No, if I'll do new thing, you guys will won't understand. So see, it's a primary halogenoalkane, right? Now I have one equation for you. You guys can take the picture of this for a reference and then draw me the mechanism of the second one. Yeah, that is removed from the original molecule. Okay, so here you go. So if you see, as the bromine is bonded to a carbon, that carbon has still 2 hydrogens. So this is a primary halogenoalkane. And the difference is that instead of hydroxide, the cyanide ion will be the nucleophile. So it will again go SN1 or SN2. It will also undergo SN2 mechanism, the same mechanism as we have discussed. Okay, just wait. So have a look. This is the mechanism. So it's the same mechanism. What happens that the carbon from its lone pair attacks the carbon, and this bromine snatches the whole bond pair. And as a result, see, we can again got this transition stage where the both bond making and bond breaking is shown. And as a result, the bromide gets away and we got CN bonded to it. Okay. This is the energetics of this reaction, which is asked in MCQs. So you need to know that the energetics shows only one step, and at the highest peak, you got the transition step. Okay. Now this is your homework. Now I will check the homework. I gave you 2 homeworks. So again, these are the primary halogenoalkane. And actually, this is only a one molecule which is shown in 3 different ways. So you need to draw one mechanism. Yes. 4 to 5. Okay, take care everyone. Allah Hafiz.